When Jesus spoke again to the people, he said, I am the light of the world. Whoever follows me will never walk in darkness, but will have the light of life. John 8:12. Follow the light of Jesus, for his light gives us peace, hope, and love. Good day, MBHS Science Grade 10 learners. Welcome to our video series on electromagnetic waves. I am your teacher, Mr. Guetta. Let us have our pre-assessment activity. Kindly please get your notebook for your answers. Let us proceed. Choose the letter of the best answer. Number 1. Which is not an example of an electromagnetic wave? Letter A, radio waves. Letter B, visible light. Letter C, sound waves. And D, infrared radiation. The answer is C, sound waves. Number 2. Which of the following electromagnetic waves has the lowest frequency? Letter A, radio waves. Letter B, microwaves. Letter C, infrared radiation. And D, visible light. The answer is radio waves. Number 3. How does magnetic and electric field propagates? Letter A, parallel. Letter B, symmetrical. Letter C, perpendicular. Or letter D, no propagation. The answer is perpendicular. Number 4. Describe the relationship between wavelength and wave frequency. Letter A, direct proportional. Letter B, inverse proportional. Letter C, direct square proportional. Or D, inverse square proportional. The answer is inverse proportional. Number 5. Who discovered that electricity can produce magnetism? Letter A, Heinrich Hertz. Letter B, Michael Faraday. Letter C, James Clerk Maxwell. And D, Hans Christian Ørsted. The answer is Hans Christian Ørsted. Before we start with our lesson, let us notice the following. Have you ever wondered how light travels from sun to earth? How light affects us in so many ways? How about your TV remote control? Did you ever think, how does it work? The X-ray. It is very impressive, from broken bones to damaged tissues. It is very useful in medicine. And of course, your Android phones. Is it the most magnificent creation of the century? These are all products of the concepts of electromagnetic theory. Let us know who are the people behind the discovery of electromagnetic theory. These people gave us modern communication and transportation system and many others. The first one is Hans Christian Ørsted. In the year 1820, Ørsted discovered that a magnetic needle aligns itself perpendicularly to a current-carrying wire. This led to the conclusion that electricity produces magnetism. Next is André Marie Ampère. He discovered that a wire carrying electric current can attract or repel another wire next to it that's also carrying electric current. The attraction is magnetic, but no magnets are necessary for the effects to be seen. The unit for electric current was named after him. Next is Michael Faraday. Using the basic components such as coiled wire, magnet, and galvanometer, he discovered that magnetism produces electricity. This led to his electromagnetic induction theory, which is very important in power generation today. Heinrich Hertz. He built an apparatus that can produce an electromagnetic radiation that travels at the speed of light, which is known as electromagnetic waves or EM waves. The apparatus has become the first transmitter and receiver of electromagnetic radiation. Next is James Clerk Maxwell. His Maxwell's equation unified all the fundamental forces in nature. He found out that electricity and magnetism is the same kind of force. He also proved that light is an electromagnetic wave that linked the concept of optics with electromagnetic theory. Electromagnetic radiation propagates using electric field and magnetic field. That's why they are called electromagnetic waves. The electric field and magnetic field are perpendicular to each other. That's why EM waves are also a type of transverse wave. Electromagnetic radiation are summarized in a certain diagram called electromagnetic spectrum. It includes the following electromagnetic waves: radio waves, microwaves, infrared radiation, visible light, UV rays, X-rays, and gamma rays. They are arranged according to increasing frequency but decreasing wavelengths. Radio waves has the lowest frequency but highest in terms of wavelength, while gamma rays has highest frequency but lowest wavelength. Radio waves are used to broadcast radio and television signals, while microwave is used in cooking, radar, telephone, and other signals. Infrared radiation transmits heat from sun, fires, and radiators. Visible light makes things able to be seen by our naked eyes. Ultraviolet light absorbed by the skin used in fluorescent tubes. X-rays used to view inside of the body and object. Gamma rays is used in medicine for killing cancer cells. The wavelength, frequency, including the energy of each electromagnetic wave, is summarized in the following table. Notice that the value of wavelength decreases as it goes down the table, while the value of frequency and the value of energy increases. This indicates that as the value of wavelength decreases, the frequency increases, while energy also increases. Or it could be, as the value of wavelength increases, the value of frequency decreases, and the value of energy also decreases. For us to further analyze the relationship of variables such as wavelength, frequency, and energy, let us have this. The wavelength, or denoted as Greek letter lambda, is inversely proportional to the frequency, which is denoted as small f. Using a mathematical relationship, we can express that wavelength is inversely proportional to the frequency. Means, as the value of wavelength increases, the frequency decreases. Or, if the value of wavelength decreases, the frequency increases. If we are going to transform this into an equation, we can cross-multiply this, and this will be equal to constant, where the constant is the speed of electromagnetic, which is equivalent to c, which has a value of 3 times 10 to the 8th meter per second. The formula that represents the relationship between wavelength, frequency, and their speed is this one. How about the relationship between wave frequency and energy? They are said to be directly proportional to one another. In mathematical symbol, we can express that E is directly proportional to F. It means as the value of energy increases, the frequency increases, or as the value of energy decreases, the frequency also decreases. In equation, it will become E is equal to constant times the frequency. The constant is actually the Planck's constant, which is equivalent to 6.63 times 10 to negative 31 joule times second. The formula representing the relationship between the energy and the frequency is E is equal to H times F. Now, let us determine the units that are being used in the following variables. For wavelength, we are using meters. Wave frequency, we are using cycle per second or hertz. Speed of electromagnetic wave, meter per second. And for energy, we have joule or J. Let us have our sample problems. Number 1. Calculate the frequency of a radio wave with a wavelength of 100 meters. Let us use the GRESA method. First, we have the given. We have a wavelength of 100 meters, which is equivalently equal to 1 times 10 to the 2 meters. And the speed of light, which is constant, 3 times 10 to the 8 meter per second. Next, we have the required, which is the frequency. And then we have the equation. So from the original equation, C is equal to lambda times the wave frequency, we can solve for F by dividing both sides of the equation by lambda. We can cancel lambda, and the equation becomes F is equal to C divided by the wavelength. We can now solve the problem. Substitute the values for speed of light and the wavelength. Divide the values and cancel the units. So we will have 3 times 10 to the 6 per second, or 3 times 10 to the 6 hertz. Number 2. Calculate the wavelength of the UV light with a frequency of 3.5 times 10 to the 15 hertz. Again, let us use the GRESA approach. Given, frequency is 3.5 times 10 to the 15 hertz, or 3.5 times 10 to the 15 per second. And of course, the speed of light, which is constant, 3 times 10 to the 8 meter per second. Required, we are asked to solve for the wavelength. For our equation, based on our original equation, C is equal to lambda times F, we can solve for lambda, or the wavelength, by dividing both sides of the equation by F. We can cancel F on the other side of the equation. The equation now becomes wavelength is equal to the speed divided by the frequency. We can now substitute the value. Speed of light is equal to 3 times 10 to the 8 meter per second divided by the frequency, which is 3.5 times 10 to the 15 per second. We can cancel units, and then the answer would be 8.57 times 10 to negative 8 meters. Problem number 3. Determine the energy emitted by an X-ray with a frequency of 1 times 10 to 18 Hz. Given, frequency is 1 times 10 to 18 Hz, or 1 times 10 to 18 per second. And we have the Planck's constant, which is 6.63 times 10 to negative 31 joules second. And we are asked to solve for the energy. We have the original equation E is equal to HF. So we do not have to derive, all we have to do is to have a direct substitution. And that becomes 6.63 times 10 to negative 31 multiplied with 1 times 10 to positive 18. We can cancel unit, and that will give us 6.63 times 10 to negative 13. The answer is the energy is equivalent to 6.63 times 10 to negative 13 joules. Number 4. An infrared radiation emits 1 times 10 to negative 18 joules of energy. What is the frequency? Given, energy is equal to 1 times 10 to negative 18 joules. We have the Planck's constant, which is 6.63 times 10 to negative 31 joules second. We are asked to solve for the frequency. Based on the original equation, E is equal to H times F, we can solve for F by dividing both sides by H. We can cancel H from the other side of the equation. We have now the formula F is equal to E divided by H. We can now solve. Substitute the values. For energy, we have 1 times 10 to negative 18 joules divided by the Planck's constant, which is 6.63 times 10 to negative 31 joules second. We can cancel units. The answer now becomes 1.52 times 10 to the 12 per second, or 1.52 times 10 to 12 Hz. Let us have problem number 5. Calculate the energy of a gamma radiation with a wavelength of 1 times 10 to negative 12 meters. The given are wavelength 1 times 10 to negative 12 meters, Planck's constant, and the speed of the wave. We are asked to solve for the energy. For this problem, we are going to use two equations. The first one is speed is equal to wavelength times the frequency, where we can solve for the frequency, which is equal to the speed divided by the wavelength. And the second equation is energy is equal to Planck's constant times the frequency. We can now substitute equation 1 with our equation 2. Substituting that, we will obtain the following equation. E is equal to h times c divided by lambda. Now, we can substitute 6.63 times 10 to negative 31 joule second times 3 times 10 to the 8 meter per second divided by 1 times 10 to negative 12 meters. Evaluating first the numerator, we will have 1.989 times 10 to negative 22. Dividing that with the denominator, we will have 1 times 10 to negative 12. We can now cancel units. And the final answer, energy is equal to 1.989 times 10 to negative 10 joules. That's it for today. Let us have our post-assessment activity. Again, kindly please get your notebook for your answer. Are you ready? Let us start. Choose the letter of the best answer. Number 1. It is the only electromagnetic radiation that is visible to our eyes. Letter A. Microwaves. B. Radio waves. C. Visible light. And D. Infrared radiation. The answer is visible light. Number 2. Energy is directly proportional to the frequency. What does this statement means? A. When energy decreases, frequency increases. B. When energy increases, frequency decreases. C. When energy decreases, frequency decreases. And D. The statement has no basis. The answer is C. When energy decreases, frequency decreases. Number 4. He proved that magnetism can induce electricity. Letter A. Hans Christian Ørsted. Letter B. Andre Marie Ampere. Letter C. Michael Faraday. And letter D. Heinrich Hertz. The answer is Michael Faraday. Next, number 5. The unit used for energy is A. Meter. B. Joule. C. Hertz. D. Meters per second. The answer is Joule. And last question. The electromagnetic waves that can cure cancer is letter A. X-ray. Letter B. Gamma rays. Letter C. Radio waves. And lastly, infrared radiation. The answer is gamma rays. Before we end our video for today, let us think the sources of our picture for today's video. I do not own the pictures used in this video. This is used only for educational purposes. Thank you so much. And for you, my dear students, thank you again for watching our video. Keep on learning and happy learning. God bless always.